Today we're going to talk about men from Mars, women from Venus, both can code .NET in Jupyter. Here's the backstory why I chose this title. Let me tell you a little bit about me and myself and my wife. My name is Ron Dagdag. My wife is Leodette. We're both .NET developers. I've been a .NET developer since 2005, and my wife, she started 2 years ahead of me. We went to the same school, but we learned .NET at work after we started doing development. We've been web developers since 2000, but she started doing .NET development since 2003. My wife started with .NET Framework 1.0, and I started with .NET Framework 2.0. My current work today, I do a lot of .NET Core. I work for a startup called Spacey, where we do a lot of AR and IoT applications in .NET. My wife, on the other hand, works for a large enterprise application. She uses a lot of .NET Framework, and of course, it's something that's already been out there for a long time. It's a software that makes lots of money. And lately, she's been getting into Azure as a DevOps engineer, and she's taken her certification. And so she's going to start working with .NET Core also eventually. So I know we both live in the .NET solar system, where we're like in two different worlds, right? I live in the .NET Core world. She lives in the .NET Framework world. But they're both .NET. And then I kept on hearing this. There's another world out there, and it's the world of Jupyter and data science. And I've heard that Pythonistas live there. And that's the truth, because they have a mug that is available. You can buy your own Pythonista mug. So they exist. So today we're going to talk about what is Jupyter, and we'll talk a little bit about .NET Interactive and how it connects to .NET in Jupyter Notebooks. Then we'll incorporate it and run it on a Raspberry Pi as part of my demo this morning. And eventually, we'll land somewhere in Jupyter. So Jupyter is an open source web application since 2015. It was created to share a document, create documents that has combination of live code, instructions, live text. It's like documenting your code, at the same time equations, anything related to visualization. At the end of the day, what it's trying to do, or what it's made for, is for interactive data science and scientific computing. Something that you would interact with data, manipulate the data, and then you're done. One advantage of also using Jupyter Notebook is, if you have a bunch of command line tools that you want to run, right? And it's a way for someone to document what are those for, rather than giving instructions on a different document and the user have to go to, or the next person had to go to another page to run each line of, each command line. So that's one way that we can use Jupyter Notebooks. It's actually started with 3 kernels. They call it kernels is because those are the languages that are available, that is running in the backend that you can use. It started with Julia, Python, and R. That's where they came out with Jupyter. And then, of course, it used to be called IPython Notebook, and eventually it got changed to Jupyter. .NET Interactive is is bringing .NET to any interactive experience. So it's not just limited to. So this is an open source project, but it's not just limited to Jupyter, but it's also you can use Interact and Visual Studio Code. It's also a way to share code, explore data, write and learn different applications. And so it's a one way for someone that's starting to learn .NET or starting to understand what .NET is without the the way we've done it in the past is you have to install the whole .NET framework. You have to install Visual Studio. It takes an hour just to get things started. So this makes it easier for someone that is new to .NET to learn and explore data. So in .NET and Jupyter Notebooks allows us to have different kinds of kernels. By default, Python and R is part of that kernel. But with .NET Interactive installed, you have .NET, C#, F#, and one thing that's also new is PowerShell. So if you want to document your PowerShell commands or even your Azure commands, right? And for you, it's a way for us to be able to do that. It also has that capability of these magic commands that you can switch from one kernel to the other, and I will show you more later on. And also the idea of a pocket view where it allows you to display HTML, create links, and to make the document easier to understand or better. For data visualization, there's XPlot that you can use also. This one allows you to have charts, text, equations, SVG graphs, and all that. So if you have questions, feel free to put them in the chat. I'm open to discussion what is needed, and that's how I know also to make things interactive, right? So Azure Data Studio, if you're not familiar with that, that's also another open source project, and it's already also in GitHub that allows you to have Jupyter Notebooks in it. And if you have .NET Interactive installed in your machine, you can have PowerShell and C# and F# going in it. So just want to where's that? Data Studio. So a sample of a Data Studio would look something like this. See if I can start it up real quick. And this is a good way to get started with Jupyter Notebooks without doing a lot of the install because it's already built in for you. But there's instructions out there on how you can install the different kernels that is available. Let's see if I can close that one. So like in this case, I can have a SQL kernel, a Python kernel, PySpark, Spark and R, but it allows me to have this C#. So I can write console hello world, and then I can just click this run button. And this is our first Python notebook, right? So you have your command. We know that we're using C#, and you write your C# code, and it would respond back. And you can add another line or another code or text, right? And then I can do console write line again, right? And then just run it. Of course, you can always go back here and rerun that, and it changes the result. So of course, you can also have PowerShell commands. Think about it as a command line that gives you in the same document, the command and the result. So at least the next person who would try to run it again kind of understand what the output is. So it's a good way for transferring knowledge. Okay. Also, you can do it in Visual Studio Code. There is an extension. It's called .NET Interactive Notebook extension that you can actually open an existing Jupyter Notebook inside Visual Studio Code. It's kind of work the same way, and also convert it to this .NET Interactive Notebook. The extension would be a .dib. So it's still in preview. It's still early bits. So if you want to try it on Visual Studio Code, I just want to tell you that you can also do it that way. At the end of the day, what's happening in the background, how the magic of .NET Interactive is working, is that you have these, kernels running in the background for each one of your code. And then these are the applications that you can interact with. And it sends the data back and forth using either AZURE or HTTP to get the response back and then go back to rerun it again and create a new set or new instructions. It's extensible, so you can have you can even create a new language in the back end or in a new kernel. You can create new kernel extensions that way. Then we'll talk about Raspberry Pi. Earlier this year, I think, or last year, Raspberry Pi 4 has been released. I'm using Raspberry Pi 3, but this is a more powerful device, right, for Internet of Things. If you're interested in learning more about how to incorporate sensors, read sensor data, and control lights and all that, this would be a good introduction. And .NET runs on Raspberry Pi. And what I have on my device right now, I have it right here, right there. That's a sample. That is a SenseHat. And so this gives me extra sensors to get the temperature, and also LED lights over here that I can control. And so that's an extra sensors that you can, they call it a hat because it sits on top of Raspberry Pi, just like a hat. To install .NET, Jupyter Notebook, and also install .NET in Raspberry Pi, there is a shell script command that you can run, and this would execute Jupyter Lab and install it on Raspberry Pi. And installation instructions to enable SenseHat in Raspberry Pi. There's a lot of documentation out there that I'm not going to cover in my session today. So let's go to our Jupyter Notebook right here. So I'm running it on Raspberry Pi right now, which is on this one right here, but I have it on the browser. I have it shared, so I'm actually executing it remotely. So if I want to SSH on the box, since I already have Raspberry Pi, or I already have .NET and Jupyter Notebook running on here, I can just create a terminal and it would open up a new terminal just like this. So I have contents of, just like I SSH to the box. And if I want to, there's of course the Jupyter is already installed after I run that app, but you can say Jupyter kernel spec list, and it would list you all the possible kernels that Jupyter offers. Okay. So let's go to, looking at code, because sometimes so after you install that, you can create your own application, file new, right? And you can select .NET C# here as a new notebook. And in this case, I created one for our presentation today. And so the first command that is available in Jupyter Notebook is this lsmagic. lsmagic kind of lists you all the possible kernels that are available. That is, and also you can do HTML, you can do JavaScript, you can mix and match, you can do actually markdown. So these are markdown. So notice that you can create each cell. It has this idea of cells. So when you create a new cell, you click plus. Right now, that cell, it's either can be a code, a markdown, or raw. Code meaning it's in this case, this is a C# kernel, right? So I write C# code, or a markdown. And when I click run, right, and I will have the markdown command. And then you have the lsmagic, which kind of gives you idea of what are the possible things that you can call. And then we'll move to, if I want to call F#, right, that's because that's what it tells me here. I can call F#, right? I can say hashtag bang F#, and this is an F# code. I would assign X to 10 and Y to 15. So let's see if I can run that. And if I want to grab a variable from my F# kernel and transfer it to my C# app, I can do share from F#, the variable, which is this X right here. And then I want to display it. So I can just call that variable and display it. So I can mix and match if I want to have an F# code or C# code in one area. And then on here, I have my NuGet application, or this is how you would add or reference a NuGet library. Like in this case, you specify which one and then the version. Like in this case, it's gonna download all the NuGet, all these three over the internet. So let's see how that one goes. So it looks like it's done because it tells me that that number here, 53, see, every time you run it, it increments. And if it's blank, that means it hasn't run yet. And when it's running, you'll see that there's an asterisk there. So there's also a concept of pocket view. Pocket view allows me to create HTML tags in my in here. So like in this case, I want to do an href with the link to the to the presentation. So if you're interested in learning, in getting the Python notebook or the Jupyter notebook, you can do that. And to display it, it's already built in. You write display and pocket view. And when it renders, I have a link. I click on it. It opens up that presentation, and you'll see that here, and the PDF of my presentation. Moving along, so this one right here, you can also specify, hey, I want an HTML, and I want it bold, and I just want to display whatever that HTML is. Enter data. There you go. Guys, if you have some questions, feel free to add them in the chat. Okay, so in this case, what I'm doing, remember we added these NuGet packages. This one right here, the system.device.gpio, allows me to have the IoT bindings on Raspberry Pi, so I can control, the input and output of Raspberry Pi, this IoT device binding allows me to have all these different libraries that is available out there that I can, in this case, one of them is this IoT.device.sensehat, which is, it's already built in to the .NET IoT library. So what I'm doing here is I would like to access the SenseHat. I would like to do it 10 times, right? Go loop through and get the temperature. And once I have the temperature, I want to display it here. See that temp output? I want to update and change, the temperature that I got displayed here, and then wait for half a second and then go through it again. Okay, so that's what it's doing there. So we're gonna call it read temperature, call it 10 times, do 15 times, and run it. Notice how it's changing here. And of course, if I want to call it again after it's done, I can do that. And experiment. Yeah, that's the idea here. It's interaction. I don't have to go recompile the code. It just runs in the background for me. Now since we've added the temperatures to a list, I have a tuple on my list, which is a combination of, an ID and the value that I got, right? So what I want to do here is I want to include this xplot.plotly, and I want to grab, I can use link, right, to be able to grab all the values from that list of tuples and display them. So those are the values I have. I have 15 of them. And then I want to display them in a scatter plot. So, that is part of this xplotly graph. Oops, sorry. Graph.scatter. You pass in x and y values. In this case, I want to pass the index and then the values. And I just want to plot them using that series and with that title. So I want to do that here. I want to display. Oh, of course, it's not going to show because I need to run this code first. And just right there, just like that, I was able to plot the sensor data that we receive from Raspberry Pi and display it. And we can also zoom in and out. It's a way interactive, right? So that's part of Plotly. So you see the idea, right? I mean, it's interactive programming. On this next step, what I want to do is I want to read that same temperature again. Okay, but this time I want to use asynchronous streams. Asynchronous streams is a way for us to get the data from our Raspberry Pi here, or the temperature from our SenseHat, and wait after a second, and then continuously do that after how many times. But since this is asynchronous, I would receive the data asynchronous too. So let's run that. I have this Microsoft data analysis that a NuGet packages that I'm adding. And it's downloading that NuGet package. After it's done, what I want to do here is I want to create two columns. One is the date time column. That's where I define this primitive data column, and the Fahrenheit column, which is of type double. So this is how you would call an asynchronous stream. You see the await for each. You specify, in this case, I want to call it 15 times. And as I call it, I would receive that data, right, from this, going back to that asynchronous stream. I would receive it as asynchronous, and it would call it, it would call this code after this yield return. So once I receive it, I would append it to this data frame columns. So let's try to run that. Now it's grabbing that data as I receive it. It's adding to these columns right here, and it's going to do that 15 times. So now what I want to do here is, after it's run, I know it's finished running, I'm going to do new data frame. I'm going to create a data frame. And this data frame would have date times and Fahrenheit, I spelled that right, column. So what I'm doing is I'm creating a table or frame that has date times and Fahrenheit. And if I want to display it, I just call df, right? Because that's my variable. And it looks something like this. So the reason why it's kind of clear how it's formatted, it's because of this magic right here. This one is allows to grab the first 5, and I'll show you. I'll change this program to I'll do the 10 items. It will grab the first item, and it would kind of make it prettier, like a table, that looks like a table. So it's creating an HTML. So now if I run it, I would grab 10 items instead of 5 items. So without this, your data frame wouldn't display correctly, because it would just be just calling. Let's go back here and see if I can call 8 times. See, that's the date times column with that index, and the Fahrenheit, that index. Right, so it kind of squished them with the same index. Okay, I'm going to move forward here. So if I want to get the first 2 rows, I can do this. df.rows.take, and that would give me the first 2 rows. And if I want to count the number of rows, right, it'll be df.rows.count. And I want to display the total, and that'll give me, there's 15 rows. So I can do columns too. How many columns do we have? 2 columns, remember? On here, what I want to do is to create a different column. It's called Celsius column. Okay. And total would be the count. So in this case, I want to go back to rows because I want to make sure the total is 15 when I create this primitive data frame column. But I want to do is I don't want to destroy. I want to clone and create a new copy of my data frame and then insert that Celsius column. So in this case, it would look something like this now. So I have the date times, which what we have originally, and the Fahrenheit, and then we added a Celsius column, and it matches because we specify 15 items on our list. So now if I want to do, there's also a command called newdf.info that would give me the data types, kind of identify, like in this case, there is the date times have 15 items in them. The Fahrenheit have 15 items in them. Celsius does not have anything yet because they're all nulls, right? It gives me the data type. So now if I want to fill the nulls and assign them to 0, I can do that. And you specify in place. So now this column right here is filled 0s. And if I want to grab the first row, I can do that. And gives me that information. In this case, what I want is to fill in the Celsius column and do conversion from Fahrenheit to Celsius. So I will grab the Fahrenheit column, 32 times 5/9. That's the formula. And now, when I run it, it converts each one based from this data right here. The same way as kind of like writing an Excel formula, right? So it would fill in my whole data frame table that way. And since I can do that, then I can calculate the mean. We know the mean of that column. This is a way to create a scatter plot. So you can create a scatter plot by doing this new df, and you specify which column is X, which column is Y. Just like that, we have a scatter plot again using data frames. So imagine if you have 1,000 rows, it will just build it for you. Okay, going to the next one. This time, I still want to read the temperature data, and you want to read it in Fahrenheit, but I want to add it to this table right here, okay? And wait after half a second and add it to that. Okay. And then I have these JavaScript program. This time, what I want to do here is to create this JavaScript code that I want to download the D3 library. If you're not familiar with D3.js, that is one way to create charts or visualize. So there's lots of examples, and if you want, this at the end of the day, it's manipulating SVG, but there's different utilities there. So D3 would get assigned to that library, and then I can just start using it. All these code is creating somehow a graph, and I'll show you a little bit what's going on here. So let's see if I can run it, this line of code. So as I receive the data, the important part that I wanted to show here is that I want to grab these, there's SVG selector. There's in order to call this function, there's two parameters, SVG selector and variable name. So in order to call this function. So in this case, I want to have an HTML code in this, and I have this data plot too, as part of its SVG. And if I want to plot it or to display it, I would like to get the notebook scope, which is defined up over here, and call plot. And what this is doing is it pass in these HTML, SVG tag, and the temp data. The temp data is coming from our C# code that would receive our temperature information as I receive it, and it would, since it's async, right, it would add it to this list. And for this JavaScript program to call or to read the C# variable, I would use interactive.c#.get variable, specifying that variable name. In this case, it's this temp data. So let's see if I can run that. Sometimes it's better to show. So this is like a graph. And that's what I defined here, where I specify in D3.js, what the graph would look like. Yeah, that's that code right there. And I'm going to call that read temp data, and as I receive that in that temp data, or as I call that temp data right over here on top, I only want to keep the last 10 items. Anything greater than the last 10 items, I throw it away. So let me show you what I'm trying to do here. Okay. Let's see if it'll show up, hopefully. You notice how it's, as I receive the temperature, it's graphing it just like a real-time dashboard. And so this is the latest one every time. And you can see that the graph or those points are changing as I receive the data. And it will do it 50 times. Cool. And now it's done. It was just still blinking. The reason why it's blinking is I specify here, like it's part of that code, to change the radius of a circle. And then after a few seconds, it goes away. So it looks like it's blinking. So that's part of the JavaScript. Okay. So now what I want to do is to get the count. Remember, I only keep the last 11 items, 10 items, and everything else as I receive it, I throw away, even though he called it 50 times. And then on here, the next one, what I want to do is I want to call these LED matrix. So that's part of the SenseHat library that is already included in the IoT bindings for .NET. And what's happening here is on this function, right, on this call, I specify if the max temperature, I specify that max temperature, if the max temperature is at a certain threshold, then I would change the matrix or the LED matrix that I have on my screen to red. So let's see how that one would go. So hopefully I can demo this properly. So right now it's about 100.6 before it would call it. So we're gonna call this await read temp condition, and I'm gonna call it 50 times. My max temperature, I'd say 100.6. See how that one would go, or 7. Always change it. So let me execute this code because I haven't run that. So now I can call that function. Oh, it already turned red because our first reading was 107. So I don't know if you saw that one. It just turned red. Right? But if I change this after a while, it's still running. I can change that to like 109. Let's see if it's gonna reach. It might reach that by the end. It's doing it 50 times. But it did light up because it was more than 107. That was our original one. But it was on the first reading. You should have had a bigger number. So let's see if I can do 101. See if that one. Do it just 10 times. Do that reading again. See, it's black. There you go. Because it reached 101, it lighted up. And if I want to clear it out, I can call that LED matrix again and turn it off. Cool. Okay, that is the end of our demo. Let's go back to our presentation. So if you're interested in getting the link to my presentation material, there's that link right there. If you're interested in learning more about me, my name is Ron Dagdag. I'm a lead software engineer at Spacey. I'm a Microsoft MVP. The best way to contact me is through Twitter or LinkedIn. I really appreciate your time and feedback to improve my presentation skills. Any questions so far? I know I did finish a little bit early. I have another demo that I can show if anyone is interested, but I did demo that yesterday, which I would show here. If there are no questions, I want to make sure that I cover if anyone have any questions. Isn't that interesting? I mean, what we did today, right? We ran .NET, not on our computer, actually run it on Raspberry Pi, which is on an ARM device, right? ARM chip. And we were able to grab our sensor data, create charts, even interact and create like a dashboard in visuals, in JavaScript, and then display and then control the LED lights in our .NET program to enable it and disable it. Cool. So in this one, since I have extra time, it looks like we end at 10:45. If you want to stay in, I want to show a little bit. This one is using anomaly detection. I did demo this yesterday if you're not in my presentation, but it's related to the same .NET. But this time, I grabbed the same temperature reading, so same temperature data. And what's different here is I receive the temperature data. I round it up because I would receive it every minute. Okay. And then as I receive it every minute, okay, it looks like my Raspberry Pi is already having trouble. I think I got too many things going on. It's underpowered for that. But this one, this is the results. So I'm just going to explain what I have here on my screen instead of running it. But there's this NuGet package that I can call that is called anomaly detector, right? And this anomaly detector, I lost the connection to Raspberry Pi. This anomaly detector would get the series, or based from that temperature sensor that I grab, I send it to this cognitive services anomaly detector, and then based from that, I will send it up to the cloud to figure out, the temperature data is anomalous or not, and if it's anomalous, it would trigger. So that's what I was doing there. So in this case, I got good data, and then the last one I set it as 200, or just a random data, and because of that, it returned, when I call the anomaly detector, it specified as true. So since it's anomaly, I did change the LED matrix to red. So anyway, I just wanted to show that because I think it's interesting in how you can mix and match. Cool. If there are no other questions, it looks like our time is up. It's 10:46. I appreciate your time. Thank you very much. Thank you. Yeah. Hopefully it's something that it's interesting. It's something that you got some information. Have a good day.